Hello, Algebra 2. This is a review of, this is covering 10.4.2, which is solving logarithmic equations. So this is the handout that was attached to Veracross and also on the resources page. And so by the end of this, you should be able to rewrite logarithmic equations in exponential form to solve them. So that's the key right there, is rewriting them in exponential form. And so if you can do that, hopefully you can get something that you can use the change of base formula on and then plug into your calculator. So for solving these are kind of some general steps or strategies. We want to use the properties of logarithms to consolidate logs on either side of the equal sign. So if we could get them to the point where we only have one log on either side of the equal sign, then we can drop the logs, or we can clear our logs, and then solve the equation that's left over. And if we have a log on, if we get to a point where we can't consolidate our logs, or we can't drop the logs, then one of the things that we could do is we can rewrite the equation in exponential form and use the change of base formula to solve that. Okay, and so we want to check things because the argument should not be negative. So we just kind of have to look at our solutions at the end of our work to see if that makes any of our arguments negative. But other than that, it's pretty straightforward. So we'll go ahead and run through the examples in the classwork. So for number 1, we're given log base 5 of x plus 1 equals 2. So this is a situation where we only have one log in the whole equation, so we're going to convert to exponential form. So I'll have my base of 5, my exponent of 2, and that equals x plus 1. And so what we did is we dropped our base down, and then we switched the x plus 1 and the 2 change sides of the equal sign. So then if we simplify that, we get 25 is x plus 1. We can subtract 1 from both sides, and we get 24 is x. And so if we look at this, if we were to plug 24 back into the original equation, it would not make our argument negative, so it's good, and that is our solution, and we're all done. Going on to the next classwork example, we have number 2, which is log base 7 of x plus 2 equals 1. So same thing, we're going to rewrite this in exponential form, right? So I drop my 7, which is my base, and then the x plus 2 and the 1 switch sides of the equal sign. And so we can say that we have 7 is x plus 2. And then we just subtract 2 from both sides, and we get 5 is x, right? And if we look at that, if we were to plug 5 back into the argument, it would not make it 0. So we're good to go there. Let's take a look at number 9. So your classwork kind of jumps around in numbering, but I'm sure it's something that you can handle. So for number 9, we have log base 6 of x squared minus 5x equals 2. So our base is 6, the exponent on that is 2, and the whole thing equals x squared minus 5x. And so if I look at this, well, this is a quadratic that I can solve. First off, though, I want to simplify some things. 6 squared will turn into 36, so 36 is x squared minus 5x. And then it would be really nice to subtract 36 from both sides. So then we have 0 is x squared minus 5x minus 36. Now this is something that you could factor with first and last. So 0 is going to be, let's see, that'll be x plus 4 and then x minus 9. So I did that with first and last in my head. And then what we can do is we can take our factors and split them up and set them both equal to 0 and solve those. So I can subtract 4, I get x is negative 4, add 9, and x is 9. So then I want to take a look at these arguments in my original equation and see if, or take a look at these solutions in my original equation and see if it makes any of those arguments negative. So if I start off by checking, let's see, I'll do this up top. I'll start off with checking x equals -4. And I really just have to check that in the argument to see if it makes the argument negative. So if I do a -4 squared minus 5 times -4, that'll give me 16 plus 20. And that'll be 36, which is positive, so we're good there. So then if I check x equals 9, that'll give me, let's see, 9 squared minus 5 times 9, so that'll be 81 minus 45, which is also 36 and positive, so that's good there. So then you have two solutions for number 9, both -4 and 9 work. So let's go on to number 10. For number 10, we have log base 3 of x is log base 3 of 2 minus x. So for this problem, we have one log on either side of the equal sign, both with a base of 3. So then we can go ahead and drop our logs, and we get x equals 2 minus x. And then we just solve this. So I'll add an x to each side. So 2x is 2. Divide both sides by 2, and x is 1. So your solution for number 10 is x is 1. So going on to number 11. For number 11, we have log base 5 of 3x over x minus 1 equals 1. So this, we only have one log on either side of the equal sign. So we'll go ahead and convert to exponential form. So my base will be 5, the exponent on that will be 1, and that'll all equal my argument, which is 3x over x minus 1. So if I simplify the left, that's a 5, and I'm going to write that as 5 over 1, and then the right is 3x over x minus 1. So now I have a situation where I have one fraction on either side of the equal sign, and that's all I have. So what I can do is I can cross multiply. So I'll get 5 times x minus 1 equals 3x, right? And so then if I distribute that 5, I get 5x minus 5 is 3x, and then I can subtract 5x from both sides, and -5 is going to be -2x, and then divide both sides by -2, and x is 5 over 2, right? And so that, if we take a look at the original problem, if I were to plug 5 over 2 in, yeah, that would still be positive. So your answer for number 11 is 5 over 2. Going on to number 12. For number 12, we have log base 4 of x plus log base 4 of 3x minus 4 equals log base 4 of 15. All right, so this is a problem where we have to consolidate our logs. So on the left side, we have two log base 4s. And so if we consolidate those, well, there's addition between them. So what that means is we're going to be multiplying the x and the 3x minus 4. So if we're multiplying that, you can kind of think about that as just distributing the x across the 3x minus 4. And so if we do that, that's going to turn into log base 4 of 3x squared minus 4x, and that'll all equal log base 4 of 15. So now we have a situation where we have only one log base 4 on either side, and so we can drop that. And so now we have just our arguments, which is going to be 3x squared minus 4x equals 15. So I can tell from this x squared term right here that this is a quadratic, and we need to set it equals to 0 to solve it. So minus 15 from both sides, and I'll get 3x squared minus 4x minus 15 is 0. And this is something that I can factor and solve with first and last. So I'll have 3x and x, and then I'll have a 3 and a 5, and we'll make the 5 positive and the 3 negative. So let's see, that'll give me negative 9 plus 5. Yep, so that works out to negative 4x. So, okay, so I factored it with first and last in my head, and then I can split up the factors and set them both equal to 0 and solve those. So I have 3x is negative 5. Divide both of those sides by 3. So then x is negative 5/3. And then I'll add 3, and I get x is 3 over here. So then if we check both of these in our original problem, if I check negative 5/3, let's see, let's make sure that doesn't make that negative. So I'm going to have 3 times negative 5/3 squared minus 4 times negative 5/3. So that'll be 3 times a positive 25 over 9 plus 20 over 3. Yeah, so that's still positive, so that'll work out fine. And then if I check 3, so I'll have 3 times 3 squared minus 4 times 3. So that'll give me 3 times 9 minus 12. So that'll be 27 minus 12, and that ends up being positive as well. So both of these are solutions. Both of them can work out. So that was number 12. So we'll go on to number 13. So for number 13, we have log base 7 of 5x equals log base 7 of 2 plus log base 7 of x minus 3. So this is another one where we have multiple logs, so we're going to consolidate them. So we only have one log on the left side, so that's not going to change. That'll still be log base 7 of 5x. On the right side, we have addition between the two, so that means we will combine 2 and x minus 3 with multiplication. So again, you can think about that as taking that 2 and distributing that across x minus 3. So if we do that, we'll get log base 7 of 2x minus 6. So now we have only one log base 7 on either side, so we can drop it, and we'll get 5x is 2x minus 6. And we can solve that, subtract 2x from both sides, so we have 3x is negative 6, divide by 3, and x is negative 2. Now, for this one, if you were to take x is negative 2, and plug that into your first one, right off the bat, you can see that that would make our argument negative 10, which is impossible. You don't even have to check it in all the other ones. So then from there, because it makes that argument negative, we would say no solution for number 13. So the last example from your classwork is number 14. So for that one, we have log base 5 of 9x, minus log base 5 of x squared minus 2 equals log base 5 of 6. So for this one, again, we have multiple logs, so we're going to want to combine them. So on the left side, this will give me log base 5 of 9x divided by x squared minus 2. Right, so I'm using division to combine these because I have subtraction between the two logs. And then that equals log base 5 of 6. So now I have one log base 5 on either side of the equal sign, so I can get rid of that. And so then I'll have 9x over x squared minus 2 equals 6 over 1. And so what I could do here is I could cross multiply to solve this. And so if I cross multiply, I get 9x is 6 times x squared minus 6. Right? And so if we simplify this, we'll have 9x is 6x squared minus 36. So I'm going to minus 9x from both sides, and so 0 is 6x squared minus 9x minus 36. And so this is something that we can factor with first and last to solve. So actually, I'm going to do this one out. Let's see. Let's go ahead and we'll do this out. So we'll have 6 is first. Our last is negative 36. And then in the middle, we have negative 9. So let's go ahead and try a 2 and a 3. And let's see if we do some combination of 4 and 9. 4 and 9, we can make that negative. So if I cross multiply, I get negative 18. If I cross there, that'll give me a 12. If I add these up, 12 minus 18, that gives us a negative 6. So that's not going to work. So then if I were to do, let's see, if we stick with 2 and 3, and try something with 6 and 6. So, and we'll make this one negative. So if we cross, we get a 12, and then we get a negative 18. And so if you add those up, that'll give us a negative 6. So that doesn't work either. Okay, so this is something that I tried a bunch of combinations, and this is something that actually does not factor. So we'll have to solve this with the quadratic formula. So if we use the quadratic formula on this, we'll use it on this piece right here. We can see that A is going to be A is going to be 6. A is going to be 6. B is going to be negative 9. And then C will be negative 36. And so if we plug those numbers in, so we'll get a negative 9 plus or minus the square root of b squared. So that'll be negative 9 squared minus 4 times 6 times negative 36 all over 2 times A, all over 2 times 6. So if we go ahead and simplify that, we're going to have 9 plus or minus the square root of 81. And then this double negative here is going to turn into a positive. And then 4 times 6 times 36 is going to be 864 all over 12. So we'll have 9 plus or minus the square root of 81 plus 864, so that'll be the square root of 945 all over 12. So then going down here, we have 9 plus or minus, and then if I do, let's see, second root 945, I get 30.741. We'll cut it off at 3 decimal places. So 30.741, and that's over 12. So we've got to consider both pieces of this. We're going to have 9 plus 30.741 divided by 12. And then the other piece is 9 minus 30.741 divided by 12. Okay, so if we run those in our calculator, so 9 plus 30.741, and then divide that by 12, so we'll get 3.312, and then 9 minus 30.741, divide that by 12, and we get negative 1.812. And both of these are viable solutions. Neither one will make the arguments negative. Well, actually, if I just take a quick look back at the original problem, yes. So one of them won't work. So the negative solution, negative 1.812. So negative 1.812 wouldn't work here because that would make that argument negative. But so the only solution that we're going to have here is going to be this one right here. That one won't work. So then we can say our final answer will be x is 3.312. Okay, so that's your final solution to that problem. So, and I think that was, what number was that? That was number 14. So that was the last problem for the classwork. So kind of the longest one. But you can see it ended up just being a quadratic equation. And so we just had to, it just took some time figuring out how to solve the quadratic. So hopefully that helps, and hopefully you can go ahead and try the homework on your own.